now going to go into a blizzard of lightning talks. All right? Lightning talks formats for us are very straightforward and simple. They're going to be, my iPhone has stopped working. They're going to be exactly 4 minutes. Speakers, be ready, 4 minutes. At 3 minutes and 50 seconds, you will see me come on stage, stand right next to you, and at 4 minutes, I will drag you off the stage. I'm joking, but let's not get there. Tanmay?
Yep.
Are you ready with your talk?
I am.
Okay. Over to you.
Okay, hi, I'm Tanmay. I work for Adobe, and thanks for listening to my talk. Okay, now, am I?
Go for it.
Okay, good. Okay, I'm Tanmay, I work for Adobe, and thanks for coming to my talk. Okay, that's messed up, but we'll make it work. Anyway, so my talk is about building containers for ARM. So when I say ARM, I mean the processor architecture here. We've all built containers, and we have pipelines for regular stuff when we run Golang containers on your servers or your desktops. So that's fine. That's x86. But what I want to do is show some love to my Raspberry Pis. And I was thinking maybe I can do that with the containerization, because Go cross compiles and Docker is officially supported on the ARM architecture. So why not go for it?
You got it?
Yeah, it's messed up. I don't know.
What format are you working? Oh,
PDF.
Somebody, there I see it. There I see it.
Command 1. Press command 1. Yeah.
Okay. Let's just go with it. It's fine.
Command 1. There you go. Whose laptop was it?
Yes. Leave it. It's fine. Okay. So. Moving right on. Yeah. So I have a simple service which returns the hash for any string that you give it. So I want to containerize this, and I want to run it on a Raspberry Pi. What I'm going to do first is just set up a build pipeline, normal build pipeline, which will run on x86 first, and then we'll show how to run it on ARM architectures as well. So normal pipeline looks like this. So you first need an executable, then you need to containerize it. The automate part is just to make it easier. And then the continuous integration framework just picks up from your Git repository and then does the entire build thing and spits out a Docker image whenever you push to your repository. So that's my ultimate aim right now. And I'm just going to skim over this, because one thing I do want to say, if you're using Docker to build Golang multi-stage builds, thank God for that. And yeah, again, make file just to create the Docker image and push it to the repository. Continuous integration, again, the same part. I'm just moving fast in this part because this is standard stuff. I want to move to the ARM part first. And again, yeah, so in the end, once I have all of these three things set up, when I push to my repository, I get a Docker image in the end, which I can run on my desktop or on my servers because they are x86. But I kind of want to do this, and this doesn't work right now. So if I want to run, I get an exec format error, and that's understandable because it's compiled not for ARM right now. So what kind of modifications do I need to make to my pipeline to make this work? First of all, I need to cross-compile. Seems straightforward. Go does that pretty well. And then I need to use an ARM base image. Right now I'm not using one, so that's kind of something I need to change. So I need a new Docker file, and automate is basically the same. I just need a new target in my make file, and that should work. But the third part is I am running this on Travis CI, or you can use anyone. But this runs on x86 itself. So if I want to build a Docker image, the problem is that it doesn't run all the other commands. I can cross-compile and copy the binary, but if I want to add something to the image, let's say run APK or something, APK-add or something in the Alpine, it won't work because it's running on x86. I want to do ARM commands. That's not going to work. So I need a processor emulator there. And I'm going to use QEMU for that, and we'll see it's actually quite straightforward. Most of the work's already been done, so you just need to run one command. So I go through the steps again, which I had gone through. So the only thing I need to change here is change Go OS to Linux and Go Arch to ARM, so it's going to cross-compile. That's fairly straightforward. I've changed the from line in the final image because I need the ARM image. And in the make file, I have new targets, so I will now do Docker ARM, instead of Docker, and Docker push ARM. So I can run all 4 of them and get 2 images in the end with the same pipeline. So again, this line which I have highlighted over here is the actual thing which basically registers the, I think we know about binfump. What does is that allows the execution of a file architecture which is not recognized to another user space application, which is going to be QEMU here. And so I can run my Arch stuff, ARM stuff on an x86. So my Travis will now build both of these. And if you want to read more about that, there's a blog link at the end, which you can do. And after I've run of this pipeline, I push my code to Git, and I get an ARM image as well as an x86 image, and I can run it. So that was my talk. It's just not optimal, but I want to get the idea out that it can be done, and you can push both of them together. Thank you.
Thank you. Up next, we have Ritik.
Hey everyone, I'm Ritik. I work at Gojek. I have been working in Golang since last 6 months. I'll mainly be talking about the basics of Go routines, what exactly Go routines are. Go routines are mainly the concurrency model in Golang. Whenever we need things to be done in concurrent, we use the Go routine. They are scheduled over threads. It is same as like Go programmers doesn't deal with the threads. In the same way, the OS doesn't know about the Go routines. The threads are scheduled over OS, and Go routines are scheduled over threads. Now, how the Go routines are different from threads? There are 3 things: memory consumption. So the memory, the Go routines. The creation of Go routine is very efficient. Like it takes about 2 KB of memory while creating the Go routines. And for the threads, it took about 1 MB, which is around 500 times the Go routines. And also, the stack size of Go routine can shrink and expand according to the need of the application. Because of the memory allocation of Go routines, it is very different from the threads. If you want to know about that, just read the memory allocation of Go routines. The second one is setup and tear down cost, in which the threads took, for threads it is very significant because they had to request the OS for the resources and return it when done. But in case of Go routines, the runtime handles the creation and deletion of Go routine, creation and destroy. Like another one is a switch case, which is mainly the scheduling. The threads are scheduled preemptively, but the Go routines are scheduled cooperatively. In the preemption, the OS has to, the scheduler has to store all the registers, 16 registers, and the program counter, stack pointer, all those things. But in case of Go routines, we only need the 3 pointers to store. That is why it is very lightweight. The Go routines are, let's see some summary of the scheduling part. Earlier it was process scheduling, in which the entirely process get switches while execution. It was very heavy because the OS has to store all the pointers and all the register context about the registers. Then threads comes. It is same as the processors, but they have a different thing, like they shares the memory. And then comes the Go routines. Go routines are basically scheduled cooperatively. Cooperatively, I means like Go routines. It is not. They does not rely on kernel to be manage the time sharing thing. They voluntarily yield the control to the other Go routine when at some definite points. Like these are the points: channel receiving and sending points. Whenever a channel receive and send process get blocking the system call. Whenever a system call is there, like file and network operations. Other is the Go segment, in which it is not very certain that the next Go routine will be scheduled immediately. And next one is the garbage collection. Now let's talk about how Go routines are scheduled. For this, we need to know about the 3 entities: processor, OS threads, and Go routines. Mainly the OS threads are scheduled over processors, and the Go routines are scheduled over threads. So the processor has local queues, and there is a global queue. The local queues has the runnable Go routine. The local queue has a runnable Go routines which are scheduled over the M are the OS threads. So in this way, the Go routines are scheduled like Whenever a processor is out of the queue, the number of runnable Go routines, they actually steals the Go routines from other processors. It is called the work stealing other than the work sharing. So for the optimization of preemption thing, they uses a spinning threads in which the spinning threads are two conditions like the OS threads, which is with the processor assignment waiting for a runnable Go routines, and OS threads without a processor assignment searching for looking for available Ps. So these are the mistakes we can make while using Go routines. Mainly the two are not checking the file descriptors limit while creating a lot of Go routines. You should check it if the Go routines are opening the files, and also the memory consumption when your Go routines are like allocating a lot of huge slices and all. Thank you.
Have Karthik. Oh, you have your own laptop. Okay, in the meantime, speakers who have spoken, Ugwe Consulting, one of our sponsors, has been very kind enough to get a bunch of books here and an empty bottle. You can choose whichever book you want if after you have spoken. So please go ahead. Tanmay? Good stuff. And say thank you to Ugwe. You'll find Nishant and Aditya somewhere. All right, go ahead. So the reason why we have this, for the people who are wondering why we have these lightning talks, it is actually to ensure that we get more speakers on stage to see what it feels like to be addressing a larger audience. So I would definitely request everyone to clap loudly after anyone and everyone after they have finished. Thank you.
The other windows. Arrangement, okay. Yeah. Okay.
You want to go there? You want to share it? Yeah, this is fine.
I can just expand it.
Just a second. Command plus.
So I just want to quickly talk about how to build extensible APIs in Go. Being a beginner in Go myself, I just want to share my observations and my experiences while building a simple package and basically decoupling systems in Go itself. So the objective I wanted to introduce was to reduce dependency amongst packages, especially between the core domain logic as well as the auxiliary ones, and be able to use sensible defaults during initialization, and how we can use closures, function times with Go to help us write cleaner and more extensible code. So I want to give that example by giving a small walkthrough for a health check package that I wrote. If you don't know what health check is, basically it's just an API that you can use to quickly figure out a system's underlying failures, like check systems underlying dependencies to figure out whether there are any failures or not, and fail the status code if, for example, if they're failing or not. There can be additional option information that you can fit into the health check package, which could be like an overall global timeout. If you want some observers to figure out if they are actually working properly, like if you want to check some dependencies that don't necessarily result in failure of the application, but still are essential, you may want to not fail the health check status and just but still see the errors. So basically, this is what for example, the sample error that is displayed when you run the health check package if there are any failed dependencies. So I'll just go through the code once. So basically, we'll just dive deeper right in. Basically, what we have is a health struct, which is not exported. It has some checkers and observers and a timeout configuration. If you look at the handler, which is exporting, the health struct actually implements a HTTP handler, which returns basically the struct back along. But if you look at it, it does not accept any necessary parameters because all of the dependencies are optional because it's dependent on independent applications that you build on. So some cases it could be database failure, it could be for some others it could be external service failure, etc. So you have to write your own checkers and inject it while building the HTTP handler itself. So the way you can do that is instead of using optional configuration struct, etc., that you export outside and have other packages implement them and inject back. What it does is that the other packages becomes dependent on the health check package itself because they have to implement the configuration struct, and you'll have to deal with things like null and nil or empty zero values. So basically, instead of that, you could do something like
functional options, which is basically handler is just a variadic function which which continuously accepts an array of options. And if you see what an option is, it's just a function. It's just a type for a function, which takes in a reference for the health struct and operates on it. So basically, you can have multiple implementations. One is called with checker, with observer, which takes some necessary parameters, and based on some conditions, it'll assign it to the specific, alter the health struct itself. One more thing that you can do is, and basically it just builds a server and give it back. And all the health struct itself implements a checker function. Basically, it's a checker interface. Basically, it just takes in a context, performs a check, and returns an optional error. So that's all you need to export is just one implementation interface, and all that you need to export and have others implemented. Optionally, you can also, you might also want to just provide anonymous functions as input. So you could just define another function type similar to that one. And because it's a type, you can induce some more behavior. So you could have implementation of checker func called check, which implements this, implements the same interface and performs the same operations. Later, the server HTTP just makes a lot of concurrent calls using wait groups, waits for all of them to complete. And you can also have a timeout checker to perform this check. That's it. And if you go to main.go, the wiring is pretty simple. You just provide with timeouts all of these are optional. None of these are necessary, and you don't have to use import the health check package in any rest of your packages. You just wire them in the main file. So just to summarize, okay, sorry. Just to summarize, you just always accept interfaces in your main to make it more reusable. Accept interfaces, return objects, and wire things together in main. Use sensible defaults. You can use function options and variadic arguments to implement to make your code cleaner. And don't be afraid to use first functions as first-class citizens. Yes, that's thank you.
All right. Thank you. So I'm sure most of you all have, quite a lot of you all have not actually come on stage and spoken to a large audience, right? There are quite a few of people here who are first-time speakers. So guys, correct me if I'm wrong, but it's a daunting experience to actually stand in front of people and speak, right?
Yeah, this is my first time.
Excellent. First-time speaker. Give it up for him. There's a smile coming up. There's a smile. So we know what? We love to make people uncomfortable. It's my job. Even accomplished speakers have a tough time. So to intersperse our lightning talks, we are now actually going to call on stage one of the speakers. Cassandra, you want to come on stage? Yeah, come on over. Oops. So you know what? It also helps out. Yeah, here. There's a presentation.
There's a presentation?
Yeah, we made one for you. Yeah, so here is the game we are going to play.
You're playing a game.
Yeah.
Okay.
We'll wait for the laughter to finish.
Sorry. I'm like turning red. Y'all get to see me be embarrassed right now. Okay.
My job is done. So there are going to be slides playing here. She has no idea what these slides are all about. They are in some random order, and they're crazy slides, nothing related.
Okay.
And you have to improvise and give a talk.
Okay.
Let's go for it.
So just talk about whatever the slide is.
And
But not
get a
this
feel
one,
for it.
right?
Whichever. There it starts.
This
then
one, I have to start with this one?
It's already started.
Oh, shoot. Okay. How long do I have for each slide?
It keeps changing
Okay.
automatically.
Okay, well, this is clearly a very musical gopher. And this is, oh, I love Indian food. San Francisco has really good Indian food, but coming here, generics. I would prefer not to talk about generics. I can use generic, like from Walgreens. Y'all don't have Walgreens. This is India. There's no Walgreens here. I've never been skiing. My mother broke her knee when I was a little baby, and so she refused to take me skiing, and I haven't seen snow for 2 years. Oh, Kung Fu Panda. That's my favorite guy. Oh, yeah, he's so fun. He's really bad. What is that? Well, that's some code.
Blame it on someone.
It's your fault, very clearly. It's very clearly. Is there an error there? All right. Do I still have to talk about this? You're gonna keep. Hey. That's a big computer. I had one like that too, but I didn't get to lean on it like that. My grandpa would have been really mad. Like,
That's Commander Pike.
Boss Baby. Anybody see that movie? It was a good movie, right? I didn't see it. Was it good? I don't know. He definitely looks too cool to be a baby, though. I didn't look that cool.
Context. I'll give you the context, the hint. That dude there, $2 billion scam.
I still don't. That wasn't enough context.
Well,
I'm guessing he's a
Nirav Modi did a
priest.
$2 billion scam. That's why he gets the hot chicks.
Oh, it must be. But that looks like a
Actress.
collar that looks like a priest collar.
Oh, man.
So
Actually,
that was not appropriate. $2 billion
That's
scam.
a new one.
Well, he's clearly uncomfortable, like me on this stage. I know how you feel. Oh, SWAT team. Well, that feels American. I shot a gun once, and yeah, she's a badass. Congrats to her for Women's Day. I like it. What's that? Business is important because we make money from business. Web pages are also important. What the heck is this slide? I can't even see. Yeah, you do need an address for your business generally so that you can make money from it, and websites are recommended. Is this from like 1995? That's dumpy. Feels like the garbage collector. He passed that on to me. I was going to say it looks like New York City, but in the 80s, based on the car. Ooh, who's done that? Who has done that? Oh, man. I'm too scared, but if I did, I would definitely have a GoPro attached to my head and then to my face so I could just watch myself scream. So that would be fun and scary. Really? Generics, again. Came them with a message, but they could not understand generics. Oh, well, they use bad language in there. Is that the generic? Oh, it's a UFO. You got to see that whole process for me. So this is fun. This is very generic heavy. Who did that? You get like 10 access codes for this. How did you even manage to do that? You get 10, anyone holding 10 iPhones or 5 laptops and 5 phones, you're not supposed to share that with other people. That doesn't feel right. Is that WWE? Is that what that is? I mean, he looks really uncomfortable with what's happening to him. Party, which is what we're going to be doing later tonight. Tell me that's my last slide.
Well done, Cassandra. Hey, lightning talk speakers, does that make you feel any better? All right, so let's get back to business. Thank you, Cassandra. That was wonderful. Our next speaker is Narendran with his own laptop.
Hi guys, I'm Narain and I work as a software consultant in Tarka Labs. So we do technology diagnostic consulting, and that's my Twitter handle. So I'm just going to talk or tell you a short story on how I landed in a startup which uses Go in production. But with all my 5 years, I've been writing Python, but I didn't show my Python code to them. I just showed my Go side project, which I did for 2 months. So what happened is, when I first wanted to start Go, it was around 2015, and I thought I should learn some compile language apart from Java. And coming from Python background, I loved the concurrency, true concurrency. And I started doing some side projects, but due to some job switch and Chennai floods around 2015 December, I discontinued that project and I went out of touch. Yeah, blame it on the floods. And I came to my first GopherCon around 2016 without any context. Then again, I thought I should, get back to it and learn some Go apart from doing Python in my official production work. And again, I did a side project, just a HTTP wrapper around Postgres, and again, I discontinued. Then every time I discontinued, the community kept me going. So they encouraged me to get back up, and they pointed me to the right directions and the right source code to view so that I can keep the pace. And in 2017, I decided, okay, fine, I have to sit through this. I have to make Golang a habit. Like, I have to start doing it daily. And I started 100 days of code. Most of them would know that. So you have to sit, spend every hour a day and, code something. Then after that, I did a project during that 100 days, and I showed my code, and I joined Tarka Labs as a consultant. And I'll share the lessons which I learned during that. So you should always, learn by doing. So 90% of the thing which you learn stays with you only when you implement it right away, which is doing. And it's okay to fall down, but it's not okay to stay down. So if every time I fell down, the people from the community, they picked me up and they showed me the right directions. If you take the analogy, like I was falling down like Bruce Wayne, and the community picked me up like Alfred. It's okay if you don't get the analogy. And of course, always community before the code. Engage with people. There are so many awesome Gophers in Twitter, people from Microsoft, and William is here. Unfortunately, Steve is not here. I was expecting him here. And yeah, engage more with the community. So willpower is costly. The first 2 years, I was like, I set a goal that I have to finish, ship the side projects, I have to iterate and do the sprints. But the last year, which is 2017, I was like, I wanted to embrace boredom. I just showed up every hour a day, and I went through that. So yeah, willpower is costly. So, learn to embrace boredom. That's it from me. I have 30 seconds left before you come here. And so overall from Chennai. Yeah. Now, you guys know we don't have an active community for Golang in Chennai, right? Yes. So Tarka Labs, we have a space there, and we are free to use. So it would be nice if you ping me with some ideas, and speakers can show up, like ping me in my Twitter handle, so we can discuss about starting or making the community active again and connecting meetups in Chennai. Thank you.
Our next speaker is Vagmi. You have your own laptop? Yeah. Okay. Rules of the game. Whenever you're coming to give your presentation, ensure that it has more than 4% battery.
Cool. Yeah. Oops. All right. All set? All right. So, whoops. Good. All right. So we're going to talk about embedding resources in your Go app, right? We all write simple. I mean, this is not for your production. Like a high traffic sort of thing, but say you're doing an internal sort of a management dashboard sort of thing, and then there isn't a lot of traffic in it, and then you want to keep the deployment simple, right? So you have a Go binary, which is nice, but then you have all this JavaScript, HTML, CSS, mostly your React craft that comes along with it, and then you want to also ship it along with this so that the deployment becomes simple. The question really is not why, but why not? And I think the more interesting question is how do we do that? So let me just quickly take you on a tour of that. So whenever you build this, I hope this is, it's not, whoa, wow. Some help, please. So whenever you build this, right? So I have a simple app, and whenever you build this, I mean, it's not purely a static binary. So if you do a O2 or LDD on your this thing, you'd find that it has a whole bunch of things that are linked to it actually. Now, if you actually want to build a real binary, so I have a makefile which actually does the cgo enable. I mean, it does this go build -a and all this kind of things, which actually generates a proper static binary. So you could do a make OSX on my thing, and then this would, what it also does is that it tries to get in other version information and all that as well. So I'll do a npm start as well. So this is your dev workflow. So you have your React app that's running, and then you usually have your Go app that's running, and then you'd hit localhost 3000 and something happens here. And I have my backend proxied here, so that's running on a different port, and I'm doing this. And whenever you want to stick this in, you would do an npm run build. So I'm using this library called static, or a tool called static, which allows you to take all your client build files and stick it into one file. So when I run this, you would actually see a horrible file like this. You don't check it into source control, but it just contains all the binary information that you have in your client build, and it just puts it into one big variable, and it registers it with the fs package from static. Once that's done, so you can actually run. So there's this special comment on main.go that calls a go generate tool. So go generate is kind of a tool that lets you. So if you have these annotated or any of your Go files, it would basically run that command, and it will generate this. So when I do a go generate, so I have already built, for the interest of time, I've already built the client library, so I'll kill the npm package. Now this would create the static Go, and I can run make OSX. And this would actually take the static Go and build the whole thing into one binary. And it will include all the static resources as well. So let me run the binary again. And if I hit 45, which is actually my Go library. So this actually serves the static files also from the Go binary. So all you have to do is just distribute the Go binary, and it has all the static resources also inside it. And I have. That's my talk, and I have this up on the code as well, and I also have a Docker file on it because, yeah, why not? I mean, we are used to shipping our dev laptops along with the production thing. So that's it.
Thank you.
Hi, how many of you are students here? How many students? This is specially tailored to students, so pay attention. So this is about Golang at GSOC. How many of you know what GSOC is? Google Summer of Code. How many of you are ex-GSOCers? So yeah. So GSOC is Google Summer of Code, for those of you who don't know. It's a program by Google to promote open source contributions among students. So essentially, you get to spend your entire summer working on open source. You get paid for that, a lot of money. And the best thing is you get assigned a mentor. Essentially, one of the hardest things about contributing to open source is you get stuck on problems. Now you have someone you can ping at any time to help you fix that problem. And that's one of the biggest deals about Google Summer of Code. Now, why should you do Google Summer of Code, or why should you tell your friends to do Google Summer of Code? So essentially, I can illustrate it from my story. I was just a normal intern at a normal startup, and I deployed Prometheus, which is one of the popular monitoring systems now. And then after my internship, there was Google Summer of Code. And I was like, okay, I know Prometheus, and now there's GSOC with Prometheus, why not contribute? So I started contributing, and I kept contributing, and now I'm part of the Prometheus team. And the best part is, I had amazing mentorship, and now I have friends all over the world for all the things. So all the companies here, if you go to them and tell them, hey, I successfully completed a GSOC, they'll instantly hire you. Trust me, they do that. It's a huge thing on your resume, and it has a huge impact on your career. It kind of eases your way into Google if you're interested to go to Google. So now coming to Google Summer of Code 2018, there's a lot of organizations. Each of them have a lot of projects. Like there's like more than, 3,000 or 4,000 projects out there for you to choose one so that you can work on the summer. I don't have time for all, so this is how the UI looks. It also has several categories that you can choose if you're interested. Some highlights from the Golang community. So how many of you have heard of the Elk Stack? The company behind that is on GSOC. There's a new thing coming up called Open Census from Google. It's very, like in the beginning stages, you can make a lot of impact there. There's something called Score, which has a lot of cloud computing stuff if you're interested in that. And one of my favorites is Matrix. It's a decentralized communication platform that I use to chat with my other Prometheus friends. So, and finally comes CNCF. How many of you heard of the CNCF? So, how many of you heard of Kubernetes, Prometheus? So all these projects are under CNCF, and this is where I did my GSOC. So it has like all these amazing projects with a lot of velocity and a lot of visibility. So if you come to a conference and say, hey, I contribute to Kubernetes, a lot of people will listen to you, and that's the visibility you get. And it also has, like, I cannot tell you how nice the people are in this community. Like, literally, I know from Kubernetes and Prometheus from my friends, like they're really, really, really nice. So if you're stuck on even a very trivial problem, you won't be hesitant to ask, and they will be very helpful to you, and that's important. And also, if you do well, you'll have chances to travel around the world for conferences. So these are all the projects. 90% of these projects have Go. There's also, again, there's like a lot of organizations, and there's a lot of non-Go projects. So you can look at all of those. For those of you who think, hey, I don't know Go, I'm new to Go, I didn't do a lot of Go, that's okay. Like, it's completely okay. I didn't do any serious Go before I started GSOC. Nikita, one of my friends who's going to be here, she contributed to Kubernetes, and that's a beast of a code base, and beast is a very nice word. And she did very, very little Go before starting. You can learn on the job, and you have mentors and a lot of time to pick up the skills. So yeah, just do it. If you have any questions, if you have friends who have questions, feel free to contact me. You have more than 2 weeks to contribute, so do it.
Up next, we have Dinesh.
And how many of you know Go and you're in a state that like pretty much know Go and then like there's not much to learn? Raise your hands. Wow, I'm surprised about the humbleness. But still, it's simple, and then pretty much a lot of people understand it. I just want to ruin that experience that like there are a lot of nuances that you have to know. And these are some of the points, that's it. So it's just a small thing. If true, print some, this is a silly question. And if not, yeah, you have to abandon your assumptions. And there's some other statement. How many of you think this will be printed? You have to raise your hands. Surprise, okay, seriously. So let's just do it, but you would be surprised that like true is not true, which is weird. Like I'm actually surprised that like why less people raise their hands. So basically, this true is not a reserved word. What I did is I have another file in my package, and basically I can redefine the constant. So basically, it's not a reserved keyword. You can actually replace it. If you don't like someone or someone's project, don't please go and do it. Okay? So given that, so this is the same thing. And the other thing is, let's say you have a function method receiver on a particular struct, and you want to call a function, right? So this is a gopher, simple gopher. But default value, we know that a lot of default value for interfaces, different integer is 0, stuff like that. So if you have this content, we would expect it to fail because it's null. but it prints out something. So if you are used to the thing that you can actually return something, basically interface, if you're writing something generic function, if you have tried this, it's actually weird. Because you can actually call a method even on a nil, so it's actually valid. It's not like you will get a nil pointer exception. So watch out for this. And yeah, so this one. So you have a function which takes a slice, and then it takes an integer which you are cutting down some slice from it. So let's say I'm passing a slice with 5 digits, and then I'm slicing out 2 out of it. And then I'm just appending a random number into the sub-slice. Okay? So you will get this slice, like 1, 2, and then I'm appending something to the new slice, right? Ideally, you wouldn't expect this to change and the new result to be changed. Let's just print it. So this is the original array, and this is the slice array under the surprise. So the reason is, you can actually notice, the slice doesn't actually give you a new memory, but rather it is a pointing to the same backed array. So which means, if you don't deal with it carefully, you're going to change the old original backing array, so which is what had happened. So you can actually see here, it's all pointing to the same address, right? So, but to fix it, what you can do is, there is something called 3-indexing slicing, which actually restricts the capacity and length to be same. And the moment you add another element, your whole slice will be in a different place. So if we do this, then run it, our original slice is not affected. So there are changes in Go 1.10, which actually added it to some split function, some functions on string. So if you didn't upgrade it, you should ideally upgrade to Go 1.10. And one more thing, yeah. So you have a map. On string, you have structs, right? And then if you try to access the map and then try to change it, you can't actually change it. Because it's actually called addressable. What it means is, the same concept, right? Just now you saw, if you exceed the memory, you're going to reside into a new place and then copy it. So the same way, since this is not possible, because map value can change because you keep adding stuff, you can't address it. But rather, you can use pointer, that way it will work. One more thing is, watch out for goroutines, because if there is no one to push it, the subscribers will be blocked. So be careful, and then don't just directly depend on the goroutines channel, but rather use the forever channel. Like, you can use a for loop, a forever loop, and then select case inside it, and always use a context, and then use, you have to have a channel, and then listening on some OS signals, which is an interrupt or stop, and then that way you have to, you can actually close other things. Yeah, so there are a lot of gotchas. Sorry. The point is, there are a lot of things which you don't know. You still can explore and then read it. That's it. Thank you.
Hello. Okay. Good evening, everyone, and thanks GopherCon for having my lightning talk here. I'm going to talk about Proctor, an automation framework that we've built at Gojek. This is a framework where anyone can add scripts to be automated, and anyone can use them. So the moment someone says automation, people suddenly start thinking about infrastructure automation or test automation. But this is a much more generic automation framework, wherein you can even do background processing, like you can have a Lambda function defined as automation. And in your application, instead of sending a job to a queue, you can send a job to Proctor. It will process it asynchronously for you. So let's start. So what I'm going to talk about is the problems that we are facing and the solution that we have built. So yeah. The problems, okay. Proctor is everyone can contribute to automation and everyone can use automation. And automation, as you would have seen in our CTO Niranjan's talk today, that it's very important. And what it is delegating repetitive tasks done manually by wetware to the hardware. So let's talk about legacy solutions for automation at Gojek. First was running automation through local machine. There were 3 major problems over here. The first one was that all the automation was inside a single repository. and the dependency needed to be on the local dev's machine. So if you have to use automation, you have to install all the dependency on your local machine. Then collaboration was difficult. There were secrets checked into the code, so the repository cannot be shared across the entire organization. And yeah, then there is using Rundeck for automation. So we are using the community version of Rundeck, because of which scaling was an issue. So there are no multi-cluster nodes in community edition, just one VM. So either increase muscle power or create a new Rundeck. Then installing dependencies was tough on the VM of Rundeck. That is, you have conflicting dependencies, you need different VMs. And we needed jobs partitioned from each other. If one job is running, its side effects should not affect the another job. So yeah, and of course you are dependent on the systems team for adding jobs to the VM. Nobody had access to the VM. And third is old and gold, using Jenkins for automation. That is a CI/CD tool. So one major reason was user management and authorization on Jenkins was difficult, giving authorization access to users. Second is resource utilization was an issue. So I'll sum up our issues. That is, we needed uniformity in automation, which was missing. We needed collaboration across the organization. We need secret management, that is a license and config of a file. Then scaling up, then using automation. Across all these solutions that I gave, not the entire organization was able to use it. Only the systems team was able to use it. And they were dependent on systems team. So yeah, requirements means, yeah, your problems are your requirements. You don't need to anything else. And this is a solution we built, basically. All the issues we put together, and we built a solution, Proctor. Talking about product design is out of scope here, but I'm going to talk about it in FOSS Asia Summit coming up on 22nd March, if any of you guys are attending that. And we are going to open source Proctor, so in a few days. So you can watch out our Gojek Farm repository on GitHub for how to use it. And we'll also be releasing some blog posts and videos to help you, if you have similar issues in your organization, solve it. Thank you very much.
All right, thank you. All right, our next speaker is Kiran. All yours.
Hi, this is Kirandeep Kaur. I am a software engineer working in CloudTower Ventures, and I'm currently working on Node.js, JavaScript, and blockchain technologies. So the topic I'll be speaking about is why and how women should contribute to open source products. So I'll be sharing some data and statistics with you. So as you can see, the overall percentage of women in India is about 49%. And the overall percentage of women in white-collar jobs refers to that the women or anyone who is indulged in white-collar jobs, they have to attend office. And the overall percentage of women in engineering role is even lesser than that. So this is the first and foremost reason why women should start coming in technology and programming. Now, as you can see in this graph, the number of men in technology is increasing day by day, whereas the number of women, it's decreasing. Say, there are 29% of women, they started their careers in technology in 2016. So, after almost 12 years, that 29% will drop to 7%. And the women, they will quit their jobs. No matter what the reason is, family pressure, marriage, childbirth, sexual harassment on workplace, many more reasons, uncountable maybe. So this is the second reason that if somehow, due to any reason, a woman left her job, and if she wanted to come back to technology, then she must start contributing to open source products to get back informed. So the third reason is the percentage of women in testing versus core programming roles. The percentage of women in testing is more than in core programming or engineering roles, whereas according to the statistics, the jobs in software testing is lesser than in core programming. So these are some of the reasons the women should look into, and they should start participating in technology and programming. So why they should contribute? Now how they should contribute, how they can contribute to open source products. They should start fixing simple bugs as an initialization to any open source products. They can add or suggest new features, and they can even change the projects. They can start learning new languages. They can even ask for mentorship from experienced engineers. They can even join local technical meetups and collaborate with all the programmers. So this is how they can participate. Now we discussed why they participated, why they should participate and how they can participate. But why am I discussing this here? The only motive of these statistics and data I'm showing to you is how we all can help to increase that number of women in technology. When we see something, say something. Suppose a woman is not able to raise her voice. She's performing excellently well in her work, but she's not getting rewards for the same. So if you're seeing something like that happening anywhere, you should say, if you are capable enough or at the high position where you can raise her voice on her behalf, please do that. Carve out time as a team to share stories, data, and ideas. When you're working in a team, we should share ideas like how we can improve our work culture, work environment. And one such topics in that debates or in that team discussions could be how to make work environment comfortable enough for a women engineer to thrive in that environment. Third, we can do is to listen. If a women engineer or even if a women employee is asking you or is proposing any change, then we should listen. Leaders. How leaders like team leads and managers, what they can do. They can share an anonymous feedback form to all their team members and ask them to fill that form in such a way that will help that leader or that team lead or that manager to let know that whether he has created an environment where her team members is comfortable enough to work. And that form or that thing, that step will help that team leader to know that whether the women that are working under him or her, are they comfortable, are they having any problems working, or are they having any sort of problem which she is not able to speak up in public. So that she could just share what her problems are through that anonymous form. Follow women in tech on Twitter, Quora, LinkedIn. The newcomers, if they are fixing simple bugs on any open source projects, right? So what they will do, if they are not able to solve something, they'll definitely, if they're interested enough, they'll definitely put that somewhere. They'll ask on Quora, on anywhere. So what we can do is, we should help them. No matter how dumb the question is or how knob the question is, please try to help them and answer that question if you have time. Please do that. The last point is, ask a woman about the experience. Suppose a woman is promoted to a new job. You can ask her that if she's comfortable in her new job responsibilities, is she having any problems working, or is she need any help? No. If she's starting a new company, you can just do that same. No matter how many points or how many solutions we search or we discuss here, the only problems and the solutions which a woman is facing only she could tell you that this is the problem I'm facing and this is the probable solution I could get. So ask a woman about her experience. This is how we all can help to increase that number in technology. Thank you. But I would like to add something, that why does it matter? No, there is a problem, there is a solution, and we can do that. But why we should do that? No, we don't have time. Everyone is busy. They don't have time to answer the dumbest or the noob question. A stranger woman, I don't know that woman. No, I'll not be able to meet her anywhere. So why should I help her? Because it's time to contribute to society. It's time to think that any industry, any company, any organization will raise to its full potential only when a woman will raise to its full potential. Thank you.
I think she deserves a standing ovation. Hang on. Thank you so much. Interesting. Come on over. We say, bring it on. Yes, sir.
So I do not entirely agree with her talk because there is a difference. So there is a concept of that there should be equality of opportunity, not equality of outcome. There should be equality for all women to enter a workplace and they should be given the same opportunity, but it is not necessary to have the same number of women as outcome because it may not be entirely possible. For example, in nursing, more women choose, but less men choose that job. So this was also not an entirely tech talk. It was not. Okay? Second thing, so whatever questions you said that so when you said,
gentlemen, that was very specific. This is a debate. It's a pretty interesting topic. I know I could have stopped it long back. Let's close this. It's important. It's important for us to understand this, at least from the other side too. Okay? I'm sorry for spoiling our schedule, but let's get this through.
Yeah. So what I was asking is, wherever this slide mentions a woman, why shouldn't we not mention a good engineer? That if a good engineer is trying to raise a point, help him. If a good engineer is trying to raise a point, help him. Why should a gender matter in this case?
And let's now actually restrict this to like the next 2 minutes max, okay?
So I am not into any gender, I am not saying.
You don't want to reverse the roles, right? You're the speaker. Go for it. I'm there with you. Go. Hey, hang on. All right, please go ahead.
So I'm not saying that a good engineer or a woman, I'm just saying that the number are less for the opportunities the women are getting are lesser. Why? Because a man is never pressurized for marriage. A man is never asked to leave their job and their home to get married. A man never okay.
No, you're right.
It's kind of getting emotional, and it's
go for it.
A man never gave birth to a child. Only a woman do.
Okay.
So
So hang on, partner. The intent was not to see who's good or who's bad and what should be or what should not be. The intent is to give everyone the right opportunities. What she's talking about, women in tech, we completely support you and we will do our best to ensure that all of us pledge to help a lot of women in whatever way we can in tech. And when we say women, it also means we will also help all the men. All right? Now, I call that for a close. Thank you. Thank you. I think I just lost some hair. All right, our next speaker is Sonia.
Now I think all the audience is active. So yes, before to start, I would like to introduce myself. I am Sonia Vyas. I am from Rajaram Bapu Institute of Technology, Islampur, Sakrade. So today I take the, already we know that right from morning we are having awesome talks, and I think not much has left for me. Still today I take the opportunity to discuss with you all CI/CD with Go. So delivering continuously. So as we all know that art of building software is a craft that takes many years to develop. So earlier in our careers, we used to believe that like more the lines of code, more the good developers we are. Like the cool factor of application is because of more lines of code. But as we move over the misconception, we drew the conclusion the other way around. Like lesser the lines of code, the cool is the application is. But again, you move somewhat further. Now the world speaks out like there is no any direct correlation between lines of code and your cool factor. It's only about when you have pre-idea about what the product is going to do, what it should be do. So all I want to, the point I want to make is like, first you should have a predictable outcome what the product has to be done. So like earlier we used to fear for the dreadful release, but now we need to do it again and again. So this is all about delivering continuously. Now you can't deny the fact that we are not going to release continuously, but you have to. So with this continuous delivery, Docker can help you. So I think much of the audience will already be aware of that. So still I would like to introduce. Docker is container tool that utilizes Linux kernel features such as C groups and namespaces to provide isolation of network, file and memory resources without resorting to full virtual machine. And since you all know that these are lightweight and single server or virtual machine, they can run several containers simultaneously, and you don't need to worry about your local machine, like what other resources are installed and either it is going to conflict with that. So why to use Docker with this as far as continuous delivery is a concern? So it will give you an ability to create an immutable release. No need to worry about installing dependencies. Like if, for example, given you have a Docker image and there has to be a service run, there need to be a service run across it. So directly if you fetch the image and you run, you will find the service running. So there you see that there is nothing kind of you need to worry about what other resources you need, what other development environment you need. There is nothing kind of thing there. So next comes continuous integration. Depending on your background, you may already be familiar with other continuous integration tools as well, like TeamCity and Jenkins, etc. But what is so fancy with this worker again? So worker is again infrastructure which doesn't reside on your workstation. You like Docker as well. Docker like you doesn't need to bother about your target machine, and especially you don't need to hand over your credit cards because when it comes to developer, they often needlessly spend money. So this will help you, as it is simple, this will help you. It's incredibly easy to set up. So when you go with worker and go, when you go along with worker and go, all you need to do is, all you will be dealing with config.yml, all the steps you need to do there, and then you will have your application going with it. So thank you. So lastly, I would like to thank all the GopherCon team, so providing me opportunity for this. Thank you, one and all.
Thank you. And our last lightning talk of the day, Budram.
Good evening, everyone. My name is Budram. I'm from Red Hat, and yeah, I like to volunteer in this event, like GopherCon. Okay, so I just want to give you a glimpse of Godot. It's a BDD framework for Golang language, and let's directly jump into the. So. So this is based on Gherkin language. It's like a business-driven BDD, behavioral-driven development. And basically the tests are in the form of English, step definitions. And here it basically divided into feature files, and each feature file contains scenarios. You can see you can easily read the text. It's full English language, and it's mainly purpose for the readability and the stakeholders. So the underlying implementation is implemented in the Golang, and that's here. So you can see this, it's a regex magic. And you can see, so there are like different scenarios here that's running here, and it's, there are like there are many different, you can say, elements here. It's like scenarios, then you have given, then when, then, and there are a bunch of other things. Let me run this test. So you can run with the Godog, or you can run with the standard like a Go test. When you run it, you get this, nice output. And here you can see it just gives you the fully like documented and like automated test. You just there's no like Golang implementation listed here. Like it's not like it's fully readable tests. And okay, so there are other cool features. One thing I would like to point here is that it's not production ready, so use at your own risk. And yeah, maybe they need like community support, like from us. So let me. So another thing is like you can tag your test, and you can run those tests based on your tags, because like tags make the categories, and you can run like so you can run like this, and it basically run the same. And so if you see here, I have one feature tag. It's both I used for both the feature files, and yeah, so if I run with feature, then it will run both the feature files. So yeah, just to explore this package, so nice, and we are using it from last like 2 years. Sorry, 1 year, I guess. Okay, so another is if it happens that you write a lot of step definitions of your these scenarios, and it might happen that there are a lot of components in your projects, and you need those. There are like shared step definitions. So what you can do is you can extract it out into some similar package, and you can use that in different components. So that's what we did in our recent projects. And if you see, this is what we extracted out into integration package. And then this is the like test suite, and here we have just mentioned all the step definitions. And yeah, that's it.